Okay, welcome to the YouTube channel, Mr. Rafa Online Tuitions. Please don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions, and click on the notification button so that whenever I upload the video of this nature, you'll be able to watch and learn. We are here again to crack down the codes of chemistry 2024 GCE final examinations. In this case, we are tracking down section C. So section C consists of 3 questions. You are asked to answer any of the 2 questions. So as you are choosing the question, you need to go through, then you choose the questions in which you are going to have higher marks. So follow me as we start C1. Chemistry plays a big role in industry. Part A, explain how chemistry is used in a water treatment plant. So this is one of the importance of chemistry in industries. So chemistry is used in water treatment plants. Now here is the question, explain how. How is chemistry used in a water treatment plant? So number one, chemistry is used in a water treatment plant to balance the pH scale of water. So remember that the pH scale of water should be 7, which is neutral. Water should not be acidic, water should not be basic, but it should be neutral. So now chemistry plays an important role in a water treatment plant by balancing the pH scale of water. So to balance the pH scale of water. So now, how is the pH scale of water balanced? So calcium hydroxide, it is added in water to neutralize the acid. So very, very important. Then we can also include the second point. So chlorination. So chlorination, how about chlorination? Chlorine is added to water. So why is it added to water? In order to kill the harmful microorganisms, which are bacteria. If you want, you can say filtration. So filtration, it is used to remove sand and other small particles in water. So that is how chemistry is used in a water treatment plant, filtration. To remove sand and other small particles in water. So that is how chemistry is used in the water treatment. Figure 2.1 shows a label from a bottled mineral water called Amenshi Wumi Pure Mineral Water. So this is the label, Amenshi Wumi Pure Mineral Water, 500 mils. Then the ingredients, we have chloride ion, sodium ion, magnesium ion. The pH is 7.4. So B1, state why amenshi bumi pure Milo water is not actually pure water. So when you look at the labels here, the pH is 7.4. So the normal pH for the pure water, it must be 7. This is the normal pH of the pure water, because the pH scale is greater than 7. So that is the reason. The pH scale is greater than 7. That is the reason why it is not pure water. Part 2. If the mineral water was put in a fridge, suggest the temperature at which it would freeze. So the water, it would freeze at 0 degrees Celsius. C. What are the basic units of matter found in the mineral water, which has the label shown? So there are 3 basic units of matter. So the basic units of matter including and atoms. So these are the 3 basic units of matter. So the 3 basic units of matter, we have ions, molecules, and atoms. But here the question is, what are the basic units of matter found in the mineral water which has the label shown? So we have mineral ions. So that is number 1. So ions. Number 2, we have molecules. So here they are molecules of water. So molecules. So these are the 2 basic units of matter that are found in the mineral water which has the label shown. So part D, most metals exist as compounds in their walls. Copper is extracted from its wall, copper 2 sulfate. So that is the chemical symbol for copper 2 sulfate. Part 1, give an outline of the stages of copper production. So here they are saying give an outline of the stages of copper production. So you start with the first stage. They must be in outline. Starting with the first stage, second stage, you don't need to jumble them, whereby you start with the last stage, you come to the second stage, the third stage, then the first stage. No, you need to outline them according to the sequence. So in this case, we have D1. So the first stage in the copper production, it is concentration. Concentration by using what we call the froth flotation method. What is the purpose of the froth flotation method? What is the purpose of the froth flotation method? It is simply to remove impurities. So concentration by using froth flotation method to remove impurities. So that is stage 1. So stage 2, it is after concentration. The concentrated is roasted in air. Roasting. in air. So what is the purpose of roasting in air? To remove sulfur. To remove sulfur. So that is the purpose of roasting. Stage number 3, it is smelting. Smelting, it is simply the third stage. The last and the fourth stage, it is refining. So refining, it is simply to purify. So refining by using electrolysis method. By using electrolysis method. So electrolysis method, it is used to purify copper. So these are the 4 stages in copper production. So D2, explain why copper conducts electricity. So the reason that we are going to give, it is the reason that can be given to any substance that conducts electricity. So the reason why copper conducts electricity is that the electrons in copper, they are mobile. Mobile means they are free to move. So now those moving electrons in copper substance, they are carrying electric charges from one point to the other. So that is the reason why copper conducts electricity. So this answer, it is applicable to anything that conducts electricity. So that is our 1 mark. So because electrons in copper are free to move, if you want you can say they are mobile, are free to move, to carry electric charges. So that is the final answer. We have C2. Elena added excess calcium carbonate, that is the chemical symbol, to 50 centimeters cubic of 0.10 mole per decimeter cubic. So this is concentration of dilute hydrochloric acid, that is the symbol. So part A, construct a balanced chemical equation for the reaction. Include the state symbols. So part A, we have calcium carbonate. Calcium carbonate, it is a solid, plus hydrochloric acid. Hydrochloric acid, it is aqueous instead. So now remember that this is carbonate, this is acid. So the reaction between carbonate and an acid, it gives us salt, water, and carbon dioxide. So you need to understand the type of reaction that we have. So this reaction is a reaction of carbonate plus acid. We are going to have salt plus water plus carbon dioxide. So the salt that we are going to have, it is calcium chloride. Calcium chloride, it is aqueous, plus water, which is a liquid, plus carbon dioxide, which is a gas. So remember, carbonate, whenever carbonate reacts with an acid, what we have, it is a salt plus water plus carbon dioxide. But they are telling us a balanced chemical equation. So balanced chemical equation, we have one calcium atom. We have one calcium atom. So calcium is okay, calcium is balanced. Then we have one carbon atom. So carbon atoms, they are okay. Then we have 3 oxygen atoms. So this side we have 2 plus this one 3. So oxygen is also fine. Then we have 1 hydrogen atom. This side we have 2 hydrogen atoms. So since we have 2 hydrogen atoms this side, I'll make sure that I have 2 hydrogen atoms this side by adding a 2 in front here. So that simply means that hydrogen becomes 2. This 2 has even affected chlorine. So chlorine has become 2. Let us check the other side, chlorine. Chlorine, it is 2. Hydrogen, it is 2. So now it is a balance. Upon just adding these 2, it has affected chlorine. Chlorine has become 2. And this is a 2 as well. So this is a balanced chemical equation. So B1, the volume of gas produced in the first 2 minutes is 24 centimeters cubic. Calculate the average rate of the reaction over the first 2 minutes in centimeter cubic per second. So that simply means that per second, time is given in minutes, so time should be in seconds. So how do we calculate the average rate of reaction? So average rate of reaction is equal to change in volume divided by change in time. So in this case, we have the volume of gas produced in the first 2 minutes is 24 centimeters cubic. So we have 24 centimeters cubic divided by time. So time, it is 2 minutes. So remember that 1 minute is equal to 60 seconds. I need to change these 2 minutes, I need to change it to seconds. That is according to what we have been given as the units there. So we are changing 2 minutes to seconds. So we put x there, we cross multiply. So x is equal to 1 times x is x. So 2 times 60, it is 120 seconds. So the time taken is 120 seconds. So from there, you just use a calculator to divide. So 120 into 24. So the answer is 0.2 centimeter cubic per second. That is the average rate of reaction. So B2, the learner repeated the experiment using 50 centimeters cubic of 0.10 mole per decimeter cubic of ethanoic acid. So here, in the first part, it was that Elena added excess calcium carbonate to 50 centimeters cubic of 0.10 mole per decimeter cubic, which is concentration of dilute hydrochloric acid. That is in the first part. Now, in this part, they're saying that Elena repeated the experiment using 50 centimeters cubic of 0.10 mole per decimeter cubic of ethanoic acid. So same volume, same concentration, but different in the acid that we have. So here we have dilute hydrochloric acid. Here we have ethanoic acid. So use the kinetic particle theory to explain why the rate of the reaction is slower with ethanoic acid than with hydrochloric acid. So now both they are acids with the same volume, same concentration. Ethanoic acid, it is the weak acid. And hydrochloric acid, it is a strong acid. So now what does it mean when we say strong acid, weak acid? So now when we talk of hydrochloric acid, it ionizes completely. Okay? When we talk of hydrochloric acid ionizes completely. So if it ionizes completely, meaning we are going to have more solutes that will react. Then ethanoic acid, it's a weak acid. It's a weak acid. That simply means it ionizes partially. If it ionizes partially, then it means that it has fewer solutes that will do what? That will react. So in this case, the rate of reaction in ethanoic acid, it will be slower. In hydrochloric acid, it will be faster. So that is our objection. So because ethanoic acid has less solutes, so which are particles, solutes which are particles in a given volume, because it is a weak acid. So this causes the less number of successive collision of particles in a reaction. So this is the reason why the rate of reaction, this is the reason why the rate of reaction is slower in ethanoic acid. Part 3. How would the learner remove the excess calcium carbonate from the solution in A? So now remember that this method of preparing a salt, we call it filter and crystallization method. So now calcium carbonate, it must be in excess. In order to neutralize the acid. The remaining calcium carbonate, it must be removed by the method called filtration. So by filtration. So that is the method that we have to use to remove the excess calcium carbonate from the solution. See? So methane, that's a symbol, is a greenhouse gas. C1. What do you understand by the term greenhouse gas? So greenhouse gas is the gas in the Earth's atmosphere that traps it. So the greenhouse gas, it is a gas in the Earth's atmosphere that traps it. Another example of the greenhouse gas that we can give, it is carbon dioxide. So carbon dioxide is a good example. Another one we've been given, which is methane. So C2, the percentage of methane by volume in the air is 0.00014%. Calculate the mass of methane in 1000 centimeters cubic of air at room temperature and pressure. So now, what is the demand of the question? The demand is calculate the mass of methane. So mass of methane is equal to molar mass or relative molecular mass times number of moles. That is the formula. So do we have molar mass? So molar mass, we can find the molar mass of methane. We can find the molar mass of methane. That is step 1. So step 1 is to find the molar mass of methane. Step 1. Let's find the molar mass of methane. So here we have 4 hydrogen atoms. The mass number of hydrogen is 1. So 4 times 1, it is 4. We have 1 atom of carbon. So the mass number of carbon, it is 12. So 1 times 12, it is 12. So this is the relative atomic mass of carbon. This is the mass of carbon. And then this is the mass of hydrogen. So 4 plus 12, we are going to have 16. So 16, it is the molar mass. So the molar mass of methane, it is 16 times. We don't have the number of moles. Remember that this molar mass that we are saying molar mass is the same as the relative molecular mass, which is the Mr. So it's just the same when I say molar mass. That's why this is step 1. So step 2, do we have number of moles? No, we don't have. So let us calculate the number of moles. So for us to calculate the number of moles, what have we been given? So in this case, we've been given volume. We've been given volume, and the molar volume is given at room temperature and pressure. So now I'll use the formula to calculate the number of moles. I'll use the formula for volume. So number of moles, to calculate number of moles, I'll use volume. So volume divided by molar volume. So this is step 2. So number of moles, so N, it is mole, V, it is volume, MV, it is molar volume. So now molar volume at room temperature and pressure, remember it is 24. So this is 24. So 24 decimeters cubic at room temperature and pressure. So molar volume we have, it is 24 decimeters cubic. Now, do we have volume? So remember that this is not the volume of methane. Remember that the percentage of methane by volume in the air is 0.00014%. And calculate the mass of methane in 1000 decimeter cubic of air. So meaning we are going to calculate the volume of methane in this volume of air. So here I'll say volume is equal to the percentage is 0.00014 over 100% times the total volume of air, it is 1000 decimeters cubic. So 100 there it's 1, 100 there it is 10. 10 times 0.0014, we are going to have volume is equal to 0.0014 decimeter cubic. So this is how we are supposed to calculate the volume of methane in the air. So now from there, now I'll say number of moles is equal to volume. It is 0.0014 divided by the molar volume, it is 24. It is 24. So I'll say number of moles is equal to, when I divide, so I'm going to have 6 times 10 to the power -5. So that is the number of moles. Then now the last step. So now I have the number of moles. So I'll substitute there. So the number of moles is 6 times 10 to the power -5, which is 0.00006. Just the same. This one and this one, they are just the same. So mass is equal to, when I multiply, I'm going to have 0.0009. Don't forget the units. So that is the answer. C3. The following table shows the soil pH ranges required by different crops for growth. Crop peanut 5.0 to 6.5 range, millet 6.0 to 6.5, sunflower 6.0 to 7.5, paprika 7.0 to 8.5, mango 5.5 to 6.0. That is the pH range. Part A farmer plants peanut and millet crops. Only the peanut grows well. Predict the pH of the soil. So first of all, you should understand the pH. The pH, it's a scale that measures how acidic or alkaline a substance is. So the pH ranges from 0 to 14, where 7 it is neutral. Neutral, those things that are neutral, they are not acidic, they are not alkaline. For example, water. Then we have 1, 2, 3, 4, 5, 6. This is acidic. Then we have 8, 9, 10, 11, 12, 13, 14. This is alkaline or basic. So that is basic. So from 0 to 6.9, that is acidic. Then from 7.1 to 14, that is basic. So now predict the pH of the soil. So the pH of the soil, it is acidic. So that's where millet we have 6 to 6.5, 5 to 6.5. So it is acidic. Part 2. Which other crop is most likely to grow well in the same soil? Same soil, we have, for sunflower, we have 6 to 7.5. 7.5, which is alkaline. Okay? So paprika, we have 7 to 8.5, which is alkaline. So mango is 5 to 6. So we have mango. So mango is likely to grow well in the acidic. So most of the fruits, they grow in the acidic soil. So that is mango. Part 3. Suggest what could be done to the soil by the farmer in order for him to grow paprika. So now remember that paprika is 7 to 8.5, which is basic. So now for the farmer to grow well paprika, he must neutralize the water, the soil, by adding So suggest what should be done to the soil by the farmer in order for him to grow paprika. So paprika, it grows well in the acidic. So now that simply means that for the farmer to grow well paprika must neutralize the basic so that it becomes acidic. So neutralize the soil by adding acid. Ammonium nitrate, that is the chemical symbol, is one compound which is added to the soil by many farmers. Explain why ammonium nitrate is added to the soil. The reason is very simple. As you can see, ammonium nitrate, it contains nitrogen. So nitrogen is one of the essential elements for better growth of the plant. Remember, NKP, NKP. So NKP, these are the three essential elements for better growth of the water, the plant. So nitrogen, potassium, and phosphorus. So ammonium nitrate, it contains nitrogen. So there the answer is it contains essential element, which is nitrogen. Nitrogen for better plant growth. So that is the answer. So part C, the diagram shows part of Nylon, a condensation polymer. So for the definition of a polymer and a monomer, refer to the previous video that I made for section A, where I was able to define a polymer and a monomer. So now, this is a nylon. Deduce the chemical formula for the two monomers in nylon. So the first thing that you need to do here is you need to know what are the two monomers of the nylon. So the first monomer of the nylon, it is hexadenoic acid. So now the chemical formula for hexadenoic acid, it is carbon 6, hydrogen 10, oxygen 4. So this is the chemical formula for hexadenoic acid. Then the second monomer for nylon, it is 1,6 diaminohexane. 1,6 diaminohexane. So its chemical formula, it is carbon 6, hydrogen 12, and nitrogen 2. So these are the two chemical formulas of monomers of nylon. C2, draw the displayed molecular structures of the two monomers. So let's start with number 1, hexadenoic acid. So remember that this is an acid, okay? And you should know the functional group of an acid. The functional group of an acid, it is carbon, double oxygen, hydrogen. So this is the functional group of an acid. So this is the same functional group that I'm going to draw. So we have HOC double bond oxygen. Then now this box here, so this box here, it contains the carbon chain. Okay, so even this side, now I'll write the functional group of an acid. So this is the structure of hexadenoic acid. Let's go now to the second one. So that this box, it represents the carbon chain. It represents a carbon chain. So that is the structure of 1,6 diaminohexane. So that is the structure that is representing 1,6 diaminohexane. So D, Fishing nets used to be made from natural fibers. Many nets are now made from nylon. Suggest one advantage and one disadvantage of using nylon rather than natural fibers to make fishing nets. So let's start with advantage. So the advantage of using nylon, number one, it has high strength. It is strong. Number two, it is elastic. Ila donzomoka. Number three, it is lightweight. Yalianguka. So it has high strength, it is elastic, it is lightweight. So you can choose any one of the three. So these are the advantages of using nylon to make fishing nets. Then disadvantage of using nylon to make fishing nets. The reason is very simple. It is non-biodegradable. It is non-biodegradable. So it is non-biodegradable. So please don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions.